For letter E, we are asked to determine the particle's acceleration as a function of time and what is the instantaneous acceleration at 3 seconds. Okay, so recalling the definition of acceleration, instantaneous, so we know that acceleration, instantaneous, as a function of time, we know that this is the time derivative of our velocity as a function of time, or we also have the second derivative, okay, of our position time. Okay? Yan. So, since we have the expression or the general equation of v as a function of time earlier, then we just get the first derivative of that. So we say therefore that the time derivative, and then we plug in this v as a function of time that we got earlier. It's 2t minus 4. Okay. And then power rule ulit. So this becomes 2. And then the derivative for another constant here is 0. So this means that we have a positive 2 and then two significant figures. 2.0 unit is meter per second squared, and that is our acceleration at any time t. Okay, let's talk about the physical meaning here. Okay, now if you notice, acceleration at any time t is constant. How do we know that? Because we do not have variable t here anymore. Means that at all values of t, the acceleration of the particle will always be positive 2 meters per second per second. Okay? So that's already our answer for the second question. Since this is constant, okay, therefore, even without solving, no, conceptual na lang, that the acceleration when time is 3 is also positive 2 meters per second squared. Yan, at all times. So, what's the physical meaning of a constant acceleration? Okay, so this is an example of constant acceleration motion. Other physicists call it uniformly accelerated motion, or UAM. So what's the physical meaning of a motion whose acceleration is constant? Let's find out. To answer that, let us sketch first the velocity versus time graph and the acceleration versus time graph here. So if we recall, where is that? Ayan. This was our, let me hide this first. Okay. This is the position time graph that we sketched earlier. Okay. Yan. Constant acceleration. So, from this, we can choose, let's say, at least 2 points to make our velocity time graph. We only need 2 points, remember, to make a line. So, how do we sketch our VT graph there? Here pala. Okay. So, to sketch that, okay. So, I need to provide a space for the negative velocity also. Meaning to say, in our graph, so I'll put here time pa rin. This is in second. Gagayahin lang natin yung time interval dito. So, C1 will also be here. 1 second, 2, 3, 4, and 5. And then our y-axis will be velocity along the x. And this is in meters per second. Okay. I only need 2 points, diba? So, this is where velocity along the x is 0. This entire line here, that's the 0y. And then all of the space here is the negative velocity. Meaning, if the graph is in the first quadrant of the velocity time graph, those are the times when the particle is going to the right. Dito naman sa fourth quadrant, pag ang graph mo andito, big sabihin, sa panahon na yan, papunta siyang left. Pero, Ang difference sa position time graph, pag nasa first quadrant ang curve mo, and that would be this curve and this curve, then these are the time intervals na ang object mo nasa right side ng origin. Kasi this is position positive. Ito namang from 0.5 na curve, itong orange na ito, hanggang dito, since nasa fourth quadrant ito yung times na nasa left side siya. Okay? Now, what are the important points here? First would be the initial velocity. Now, initial velocity, so dito yan, estimate tayo ng tangent line. Ayan. So, this tangent line should be having a greater slope than this one. So, we know that when time is 1, ang slope natin dito is negative 2. Tama ba? So, let's just say that this is negative 1 meter per second, negative 2. I also have here positive 1, positive 2. So, when time is 0, the instantaneous velocity is equal to the slope of this line. If we go to our position time, ano nga yung equation natin? The equation is 2t. Saan na yun? Sorry guys. So, we have, so if time is 0, then the instantaneous velocity would be, saan na yun? Ay, I'm sorry. Oh, where is our instant? There, sorry. When time is 0, our instantaneous velocity is negative 4. So, meaning, negative 4 is somewhere here. Perhaps here. Ayan. When time is 1, we know that this is around negative 2. So, when time is 1, it's somewhere here. And then, approximately, kailan ba instantaneously at rest siya? So, kung titingnan mo sa graph natin, it would be somewhere in 2. Okay? And then dito sa time 3, since when you bisect this is just a reflection of the other side. Itong side na ito, reflection nito. Symmetrical yan kasi iisang equation lang ang buong curve na ito. So kung negative 2 dito, more or less dito kay 3, magpa-positive 2 yan siya, somewhere here. Okay? And so on. So we now have enough line. Okay? Now, take note, our velocity as a function of time here is linear. So, the best fit line natin should be straight. Okay? So, our best fit line, it's an estimation. Hindi nyo kailangang i-connect dot to dot, ha? Magbe-best fit line ka. Pag sinabing best fit line, it's your estimation of a line where most of your points are closest to it. So, in my case here, more or less, this is what my best fit line. This is how my best fit line looks like. Okay? So, take note of the velocity time graph. When time is 0, the car is moving quite fast at 4 negative. And then, nag-slow down siya. Oh, kasi bakit nag-slow down? Kasi dahan-dahan siyang lumalapit yung curve mo sa 0 velocity. Okay? So, kung magmo-motion diagram tayo dito, it means that, lagyan natin ang motion diagram, ha? So, meaning, kung ito yung origin ng particle is somewhere here, this is where x is 0, and this is going towards positive x, and this is going towards negative x. So, my particle, when time is 0, ang titingnan nyo yung position time graph. When time is 0, nasa positive 2 siya. So, when time is 0, if this is 1 meter and this is 2 meters, then yung particle ko, let's say, if this were a car, for example, so this is when time is 1 second. Andito yung particle ko sa 2 meters from the origin. And how fast is it? It's very fast. It's moving towards left at negative 4 meters per second. This is velocity instantaneous when time is 1. Tama ba? Pagdating ng 1 second, naa siya diri sa negative 1 meter. So, I'm sorry. Pagdating ng 1 second, ang particle ko somewhere nasa negative 1, nasa left. So, ang particle natin ngayon, if this were negative 1, andito na siya, yung car natin. This is at 1 second. If you look at that, 1 second siya. So, meaning, the object now, how fast is it moving? Tingin ka na naman sa velocity time mo. When time is 1, it's somewhere here in negative 2. So, medyo, kung negative 4, ganito kahaba ang vector ko, then si negative 2, kalahati lang ang haba. This is negative 2 now, meters per second. This is velocity when time is 1. Tama ba? Let's continue. Where is the particle when time is 2 seconds? When time is 2 seconds, pag sinabing where, ang titingnan mo position time graph. Okay. Where is the particle when time is 2? Okay, andito siya sa negative 2 meters. So, this is negative 1, this is negative 2, negative 3, and so on. Andito na yung particle ko sa negative 2 meters. Gaano kabilis? Dito ka ngayon titingin sa velocity time graph. When time is 2 seconds, it is at rest. So, from very fast, negative 4, after 1 second, si negative 4, nabawasan ng 2. Kaya nag-2 na lang siya. This is at, this is 0 second. I'm sorry. Correction. Negative 4 when time is 0. Pag-start ng timer. Okay? Pagpatak ng 2, nag-stop siya. So, velocity instantaneous na dito is 0. This is at 2 seconds. Kuha ba? So, nag-stop siya. Ito yung tangent line natin horizontal sa position time graph. Ito yung time to 0 velocity sa velocity versus time. So, they are in agreement. Tama ba? Therefore, we say that from time 0 to time 2, nag-slow down siya. Nag-instantaneously at rest siya when time is 0. So, dito sa graph mo, masyado siyang mabilis. And then as time goes by, velocity is going towards the 0 value. Yan naghinay-hinay na siya. Until, pagpatak ng 2 seconds, nag-stop siya. Ito na yon. So, first, dito siya, papunta very fast to the left. And then, nag-slow down, nag-stop pag 2 seconds. Are you still with me? Okay, let's continue. I'm almost done. Next. So, where is the particle now when time is 3 seconds? 3 seconds na po siya sa negative 1. So, bumalik siya dito. So, kung gagawa ako ng another motion diagram, okay, this is x equals 0. Yung car natin when time is 3, naa sa negative 1. So, dito siya ulit. This is when time is 3 seconds. Ayan. How fast is the particle? So, balik ka dito. How fast dito? So, si 3 nasa somewhere sa positive 2. To. Pero, so positive, papunta doon. This is positive 2 meters per second at 3. Tama ba? And then, pagdating ng 4, okay, steeper tangent line here. Dito naman sa 4, this is also another greater value. So, let's just say when time is 4, naa siya diri sa 2 meters ulit. Nibalik siya diri sa 2. Okay? But it's very fast. Okay. This is at 4 seconds and so on. So, meaning, from time 2 to 4, yung tangent line steepness mo, nag-increase. Nag-start siya 0. Later, mag-steeper siya. Kaharap sa right. So, that's positive. And then, steeper, steepest. So, we say that the particle here from 2 to 5 is speeding up. So, nag-instantaneously at rest siya. And then, nag-speed up siya ngayon papuntang right. Ayan, papuntang right siya. So, meaning, yung particle natin from 0 to 2, this is slowing down, pero negative x direction. Nag-stop siya dito sa 2 stops. And then pag 2 to 4, nag-speed up siya to the right. To the positive x. Pero, ang pagbabago sa velocity niya bawat segundo is constant. Kaano ka constant? It's 2 meters positive. So, meaning to say, kung nag-start siya ng negative 4 dito when time is 0, after 1 second, you have negative 4 plus positive 2. Okay? Ito, constant man siya. Okay? So, plus positive 2, nag-negative 2. Another time later, negative 2 plus positive 2, nag-0. So, that's an example of a constant acceleration. Yung pagbabago sa velocity per second is a constant number. So, dito, every second, yung instantaneous velocity na dadagdagan ng positive 2 kasi that's the acceleration. So, if we graph this, if we get the slope of this line, okay, the slope of this line, this velocity time graph, the slope of this is positive 2. And that's meter per second squared, which is equivalent to acceleration. Kaya pag i-graph natin ito, acceleration versus time, this is time in seconds, and this is acceleration along the x. This is 1, 2, 3, 4, 5 seconds. Then 1, 2, positive 2. Yung graph natin, ganyan. That's a constant acceleration. Meaning, as time goes by, the rate of change of the velocity is a constant value. Okay? So, please study and solve word problems on constant acceleration. You have several equations there. Gamitin nyo and then try to solve it. Okay? So, that's it. Thank you.